Here we have two brushless DC motors coupled together. In a moment they're going to have a fight, but first let's talk about the setup. These two brushless DC motors are connected to a single controller. The controller has three half bridges for each motor, generating three sine waves, each 120 degrees out of phase. The sine waves are synchronized to the rotor's position using three Hall effect sensors. Standard setup for controlling brushless DC motors. The PWM rate is 20 kHz, and the duty cycle is updated with each cycle. Computing three sine waves per motor with arbitrary phase, frequency, and amplitude times two motors times 20 kHz means the MCU is doing this calculation 120,000 times per second. This takes about 12% CPU utilization on a Cortex M7 running at 96 MHz. For those curious, the sine function is not being called at runtime. Here we have some RC filters for measuring the phase voltage on the oscilloscope. Okay, so I've started the right motor. As you can see on the oscilloscope, the yellow trace is connected to one of the Hall effects, and then the other three traces are the three phase. You can see they're nicely 120 degrees out of phase. If I put some resistance on the motor, it slows down and speeds back up when I release the resistance. On the right of the screen I have my terminal, the three columns here. The first column is the RPM, measured RPM. The next is the power of the right motor in percent, so it's 35%. The left motor is off, it's 0. So now I'm going to start the left motor, and immediately they're working cooperatively and the RPM increases. I can adjust the power of the left motor. RPM slows down and increase it. RPM goes back up, and turning the left motor off. Back to just the right motor running. Okay, it's almost fight time. So now what I've done is implemented a speed controller on the right motor. So if I apply some resistance, notice the power goes up. When I release the resistance, the power goes down. You can also see that on the terminal, going from 26 now to 40, 45, back down to 25. So now what we're going to do is turn on the left motor and watch them fight. Okay, so left motor on. So now if you look at the terminal, the right motor's power has gone negative. So what does that mean? The right motor is now acting as a brake, braking the left motor. And normally a brushless DC motor, the magnetic field leads the rotor by 90 degrees to generate positive torque. When it's acting as a brake, it's lagging. The magnetic field is lagging by 90 degrees to create a braking effect. So whenever the speed controller demands negative power, the motor driver switches the phases to generate that braking magnetic field. And if we increase the left motor power, the braking power increases, and if we keep decreasing the left motor, then the braking power, the right motor is switched back to positive torque. And again, if we increase the power on the left, we go back to braking mode. Very neat, yes, I think so.